Hello and welcome to this next video talking about the purpose of linear fitting. So before trying to find a Myers line, let's see what is a straight line in terms of fitting some point cloud. Well, you can understand that point clouds, after studies, may show an infinite variety of shapes. For instance, the results could be displayed like that, okay, as points gathered like that on your frame, or like that, or like that, or like that, and so on, and so on, and so on. It depends, of course, on the list of pairs XY that you obtained. Sometimes, maybe, your point cloud appears to be elongated with a straight axis, some kind of straight axis. So, a straight line would be a good model to fit this kind of cloud, and you are performing linear fitting. Sometimes, well, let's see that it could happen for the two first graphs. Sometimes it could be a curve, okay? So the variations of y with respect to x are not random at all. They try to follow some trend, but curly. And so you are confronted to finding a right function to model the situation with some curve. It could happen in the third graph and below. And sometimes for the four remaining graphs, there is no relationship between x and y. Points seem to be gathered at random, and then if you have not a good correlation between your variables, there is no way or no reason modeling that. So for this part of the chapter, we are interested in a linear fitting and the methods that could help us to find a correct straight line. So let's see in details what could be interesting in linear fitting. So just consider a point cloud. So here you've got points M1, M2, M3, and so on. In general, M subscript I. And your point cloud can be measured or located thanks to coordinates that I will name xi and yi, the coordinates of the point mi. If you want to draw now a straight line, the line D on the graph, that could go as close as possible to each point, you're interested in the differences between points and straight line, and you could calculate distances between them, but these distances will be to be counted perpendicularly to the line, and it wouldn't be very easy to do that. Um, Something that is efficient here could be to evaluate the vertical distance between points and line. That's what we will call a residue. So we have to be able to calculate the ordinate on the line corresponding to the same abscissa as the one of a point. And as the notation y is taken by the point, we have to invent to create a new notation for the ordinate on the line. So, well, let's name it simply y prime. Y will be given in an exercise. It's a result of a survey, for instance. Y prime has to be calculated thanks to the expression of the line. So y prime equals ax plus b in French notation again. Okay, and so we are able to define our residue as the difference between y and y prime. On the graph, the little distance, vertical distance between the point and the line. So there exist horizontal residues, but I won't talk about them here. I'm interested in vertical residues because of kind of reason that sometimes and most of time y is the explained value or variable, and x is the value or the variable that explains y. Okay, there is a cause and effect relationship between variables that we are studying, and Mostly, x is the cause and y is the effect. This way, the vertical distance is more interesting to study than the horizontal one. Well, whatever, that's not very important here. We can consider residues, and you can notice that if your point is above the straight line, the residue will be positive, and if your point is below the straight line, your residue will be negative. That's all. Okay, so now we will see two methods after that consider residues and the way to use them to try to choose a correct line. Uh, what is mathematically to be correct or to be as close as possible to the point. There are two methods, Myers method and least square method. See you in next videos for that, and thank you, bye.